Everybody good? Somebody signing anything? That's alright. That's alright, we got time. We're just going through this and then just give you a review. We're just going through this. Boop. There's the second one. Good. Good. There we go. There's the next one, number 3. Remember that cosine and secant go from negative to positive. Everything else, you flip the sign. So then that would make cosine x for this one, 8 over 15, which would make secant x, 15 over 8, which would make 1 plus tangent squared x equal to secant squared x. 1 plus tangent squared x equals 225 over 64. Tangent squared x equals 161 over 64, making tangent x equal to the square root of 161 over 8. So you'll have one of those on Wednesday. Good? All right, let's do some factoring. Everybody good with that one? You end up with 3 secant squared theta. The one net underneath, pulling out a GCF once again. Sine theta, 1 plus cotangent squared theta. Sine theta. Cosecant squared theta. Sine theta. 1 over sine squared theta. End up with 1 over sine theta, which is cosecant theta. Alright, these are going to be kind of mandatory. This part depends upon the problem. We'll talk about it in a moment. So if there's a direct relationship between those two, then yeah, you got to simplify more. If not, then you just leave it factored out and you move on with your life. Alright, good idea there. Everybody good? Okay, on the back. Ding-a-ding, 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 ding-a-ding. That, my friends, factors into 3 sine theta minus 1 sine theta plus 2. When you're factoring, A quadratic and the two binomials, it's only one move. You don't have to do anything else with it. You're done. However, if it's not a quadratic and you factor it into the two binomials, there may be work you have to do. So for example, 1 plus tangent squared theta is equivalent to secant squared theta, 1 minus tangent squared theta. And you're done. The reason you're done is this. Secant squared theta, and you can do this in your head, is 1 over cosine squared theta. Tangent squared theta is sine squared over cosine squared. Am I going to be able to cancel anything out by distributing? So there's no point in doing it. You're not going to simplify it anymore. So you can just get away with leaving it alone. If instead of on the bottom, this was on the top, then could you do it? Yes. All right. When your denominator looks like part of the factored form of the numerator, then I would definitely suggest factoring rather than doing the conjugate, because then the cosine theta plus 2's cancel out, leaving you with cosine theta minus 2. However, if you do want to multiply by the conjugate, you can. So that'd be cosecant theta plus 1 over cosecant theta plus 1. I would not multiply that together. I would leave it the way it is. So cosecant squared theta minus 1 times cosecant theta plus 1. The reason being is when I multiply those, the outers and inners cancel out. Give me cosecant squared theta minus 1. And then what's going to happen is those two are going to cancel out. You're leaving you with cosecant theta plus 1. Or you can factor it like you do with the one on the left. It's completely up to you. Number 4, we return to a difference of 2 squares, so that's sine squared theta plus cosine squared theta. Sine squared theta minus cosine squared theta. By your Pythagorean identities, that becomes 1. 1 times anything stays exactly the same. So I end up with sine squared theta minus cosine squared theta. When I have 4 terms, that tells me grouping. So I'm going to pull out the cosecant squared theta. That gives me cosecant theta minus 1, minus 1, cosecant theta minus 1. That's going to give me cosecant squared theta minus 1, cosecant theta minus 1. Anytime you see a trig function squared with a plus or a minus 1, you need to start thinking about your Pythagorean identities. And your Pythagorean identities that works for this one with cosecant squared and 1 is 1 plus cotangent squared equals cosecant squared. You then have to manipulate it so whatever your identity is looks like your answer. To do that, I'm going to take that positive 1, move it to the other side. So that's going to give me cotangent squared equals cosecant squared minus 1, which allows me to replace that with cotangent squared, and then cosecant theta minus 1. Again, this would be cosine over sine. This would be 1 over sine. Nothing's going to cancel out, so you can walk away a better person for it. Number 5, we return to factoring a trinomial. So that's cosine theta plus 6, cosine theta minus 2. Nothing squared, so I can leave it alone. Same thing with the one next to it, 5 cotangent theta plus 1, cotangent theta minus 3. And again, once you're done factoring that, you can be done. The first one in 6 is a little tricky, not the factoring part. Alright, it starts with a fourth. It's going to factor into a squared, so that's sine squared plus 1. Sine squared minus 3. The thing is sine squared plus 1. Alright, sine squared plus 1. Not part of any identity, so we're done. And then when I do the last one on that page, cosine squared theta times tangent squared plus 1. Tangent squared plus 1 is equivalent to secant squared theta. Secant squared by your reciprocal or inverse identities is 1 over cosine squared theta. They cancel, leaving you with a final answer of 1.